everyone. Welcome to the webinar on CICS-TS. By all means, please do jot down my email, and if I can help you out with questions after this little session, by all means, do send me emails. I answer them. Questions during the session, please use the question tab as opposed to the chat window. I really don't monitor chat window. Plus, we want the questions to get recorded along with the things. And then you can see the link there. Now, it takes you to all of our webinars, but you should be able to download the PDF of the slides and text that I'm going to present. So, very brief background. I'm one of those lovely old dogs that's learned an awful lot of new tricks. I've been working with CICS since 1969, folks. Long time. But I also work with the latest and greatest, as you can see, the web services. So I've learned an awful lot of new tricks through my career. So let's get into it. Okay. And that's happened to me before. Bear with me. Okay. It's very touchy about me first time I used the webinar. It's a little touchy about me doing things on the screens. I keep forgetting I got to put the pointer back. Okay, let's get started. Okay, so a bit about quick background, if you will, on what IBM's done here. This goes way back into mercy, 20 years ago or so. CICS-TS, they added some quick and dirty, what they called internet gateway type packs, support packs, to provide simplistic business logic that could drive like screens, if you will. Wasn't a very good implementation, but it at least started to get people thinking about using some form of a browser. This is also fairly old, but rather significant, as you'll see. They instituted what they called full HTTP support. In other words, put an HTTP server into CICS itself, which is being used by today's web services. Also instituted the new commands, and this goes back, again, probably 14 years at this point. The web API, which is in use today, we'll talk about. The document API, haven't found a lot of companies using the document API, but for your own benefit, it's basically HTML. And CICS can basically talk straight away to a web browser and put out HTML web pages. And I recently have taught a class to some systems folks and found out that they are basically doing this. And that's one of the few I have seen. The real effort as far as web services goes began with CICS-TS 3. And that is essentially the implementation of a SOAP, okay, and some other standards. Some new resources we'll take a brief look at have added support for WSRR, WebSphere Services Registry and Repository. So we will take a look at that briefly. Atom feeds or news feeds, if you will, can be done. Another thing I haven't seen a lot of use of, this service component architecture. I think I may even have removed that slide. Likewise, the event processing, if you will. This WS addressing messages we'll take a look at a few slides down the road. Okay? Now it's going to be difficult. Bear with me. Okay. So over to the next page here, next slide. And I wanted to kind of give you a brief, quick and dirty, shall we say, highlight of some of these things. Now, I'm not going to cover every little thing you see, but obviously we have had our old 3270. Bear with me here. Okay, now I see. Okay, we've had our old 3270 for a long, long time. Today, it's nothing more than software on a PC. What we're going to kind of focus on here is this web request coming in, the concept of this, something called CICS Transaction Gateway. And again, just different ways that people come in and access web services within CICS. We can do it through what's called an RPC, and I'll briefly cover what that amounts to. And of course, these are old ones. These ECI EPIs are things that were added with the Internet Gateway and a couple of other things long ago. Today, we're going to concentrate mostly on the newer technologies within CICS. So there is your brief little thing there. Okay, so as it turns out, what we're basically dealing with today in this CICS-TS version 4, you can kind of progressively see when they started adding support, they first had a web server that was not on the mainframe. Okay, that goes back way to TS 1.3. And essentially, with each subsequent release of CICS, they brought it closer. So they brought it in to the at least ZOS. Yeah, let me get my little pointer here. They brought it into at least ZOS. And then what we now have, essentially, is an HTTP server inside of CICS itself. So they've been trying to eliminate the, shall we say, middleman and bring things closer fully into CICS. So straight in from the internet TCP/IP into your CICS regions. So kind of a, if you will, and this shows an HTTP server kind of outside, but today it really is within CICS. Could we talk to HTTP servers outside of CICS? Most definitely. Okay. Now, some of the common things we have to deal with are some of the common things that, should be identified, we'll see, is we're dealing with this definition of what's called a TCP/IP service. And I'm showing you multiples here. Every service we define is going to put up what's called a CSOL transaction or a listener. And small little typo here for you. So we're coming in through a couple of different methods through TCP/IP. We have the listener that's going to listen for the inbound request coming in. It's going to determine, analyze, if you will, determine the style of requests coming in. And again, we'll talk a bit more about kind of how it does that. And invokes the proper transaction on the back end. So here we're basically showing CICS being the service provider of a web service. Now, the little kind of thing important on the front end, we can come in through standard clear text, if you will, HTTP. The IOP is really for Java. I tell folks, substitute IOP, substitute what's called RMI, remote method invocation. Because we can basically come straight in from an application into CICS. The HTTPS, or if you will, secured. CICS does support both clear text and SSL. And again, we'll talk a bit more about security at the very end. What I'm kind of showing you here is they are two completely separate entry points into CICS. So that's kind of one of the things we have to think about up front is, are we going to have some open, if you will, or some clear text coming in, or are we going to always do HTTPS? The HTTPS, the secured sockets layers, does present a challenge because we have to deal with certificates. And again, I got a few slides at the end on some comments about security. But if you are going to do HTTPS, now we're starting to deal with certificates. And that puts a little bit of pressure on the front end, if you will, because we have to authenticate these certificates. For those of you who are systems oriented, as opposed to development, you will have probably several IP service definitions, as you'll see, because there are a few other little things. And for every one of those, there will be a separate listener transaction. Now, the RPC, remote procedure call, I briefly showed you a couple slides ago something called CICS Transaction Gateway, or CTG. A lot of folks have a gateway, and again, it can sit on ZOS. CTG can sit on ZOS. It can sit also on like Z Linux on the mainframe, or even on an off-board server like a Linux server, if you will. So your web applications can then talk to the gateway, and there's several different ways to do that. But we do a remote procedure call from CTG into CICS. And for those of you who are, hopefully all of us are knowledgeable about CICS, it amounts to nothing more than exec CICS link to get inbound. So that's the so-called RPC, if you will. Okay? And again, it does do a mirror transaction, except this one here is called CPMI, and we can't override that. So it runs in that fashion. I'm trying, a lot of slides, folks, so I'm trying to. Okay, so here I got to get kind of a little bit, shall we say, a little bit more wordy, if you will. Okay, now, so TCP/IP, language of the internet, comes straight into CICS on multiple different services. I show you a single CSOL transaction, but there are going to be many. And of course, the SLTCB is the TCP it's listening on. But what I show you here is also two analyzing transactions. The CWXN is the principal analyzer, if you will, from IBM's point of view, to determine what is actually coming in. What style of web processing is coming in. Is it as simple as standard HTML? Or is it going to be, HTTP processing, which we'll see a bit about here coming up, or the full-blown heavy lifting, what's called web services in SOAP. And again, we'll briefly describe that. If you want nothing more than to get rid of your green screens, that can be accomplished real easily. Don't have a good example for you. I don't know if you hopefully have seen it, but the CWBA, the second transaction at the bottom, essentially renders what's called HTML templates. If you want quick and dirty, nothing much more than what your typical green screens are, but you would like to render it in a browser, all you simply have to do is recompile your BMS maps with a sysparm of template, put them into either a PDS or an HFS file, or ZFS file, I should say, and tell CICS where they are, and no changes to your applications. Basically, whenever your application says send map, it now will say, oh, well, I'm talking to a browser, so let me do a send template. And it is that simple. It really is. It is not the most friendliest environment in the world because none of the PF keys work. Your users are reduced to clicking buttons on the screen for PF1 through PF24. Enter key, clear key, etc. But I'm in a browser. No special software. I'm in a browser, quick and dirty. So what I'm going to focus on today for the session really is the top part, where we're dealing with the pure hardcore web services, if you will. Okay, so we have basically, as it says, service-based resources. 4 resources in the environment. TCP/IP service, which I must define as a system administrator in CICS. And we'll see a quick look at that. I'm not going to bore you to tears. It's probably the most technical slide I have, if you will. And it's just to give you an idea of what has to be defined or what has to, be set up or thought about up front. Something called a URI map. And that gets really interesting, you'll see. And I'm going to show you a bit about that one for this simple reason. CICS can be a client now. Welcome to your mainframe application being a client to somebody else. And the URI map makes it a little bit easy for me to communicate to those off mainframe platforms for my CICS application. Obviously in CICS, you are, then going to convey information to somebody else through either a standard terminal definition or, a browser-based function, but I am allowed to talk to other servers. URI maps in server mode make it a little bit easier, so I do not have to define very complex URL strings for my users. Again, we're not going to get into any details. We'll talk a bit about a resource definition called a pipeline. Again, something I must define as administrator. We'll take a brief look at the security feeds. But the URI map also has some security built into it. This Atom service is to go with the new Atom processing. Again, syndication, if you will. Got a slide coming up. A fairly new resource called a bundle. Now, this is going to get fun. With CICS-TS version 5, and I have nothing here for this, because this really is nothing to do with web services in and of itself. But IBM has defined resources called an application and a platform. And it's just another way to define my resources to CICS, like programs, files, transactions, etc. But it's a lot different than your typical RDO. And we create what's called bundles that we deploy to the mainframe. Now, as it says here, the bundle resources are really defined on a graphical environment on your desktop. They're not defined in traditional RDO transaction like CEDA, although I define where bundles live so I can go find it. I've essentially defined a bundle resource, but it's nothing more than the name and directed at the manifest or where the manifest is stored to support all the definitions, okay? But the real manifest of resources is built by a graphical tool such as RDZ or CICS Explorer. So we're starting to migrate all of our lovely stuff to some form of a graphical tool. Okay, very quickly, couple slides here, but I need to go fairly quickly, you'll see, to make the time days, the things. So I have an IP service, and of course I'm going to come up with a name. I'm going to dedicate a port. So every IP service I set up as an administrator, I got to dedicate a port for that listener to listen on. And of course that port is made known to the outside world because when they come in, they specify host name and port to communicate across. I have different criteria if I'm dealing with HTTP. Again, that's what we're going to kind of focus on here. As you can see, however, IOP, ECI, IPIC, etc. If I want one with SSL no and one with SSL yes, I have to have 2 different services, kind of like I showed you a few slides ago. That's key consideration because now I'm opening up more and more ports, more and more different connections I have to document for my people, for my users and the likes. So this is where systems folks need to think a little bit about what they truly want to support here. You know, most corporations are going to want some form of data encryption, and that's what SSL provides. Okay, and second part of this, and this is where it gets, again, kind of sticky. So I'm going to deal with certificates. And I'm basically telling it where the certificate is, and of course some level of authentication. And in most cases, basic is not good enough. So we are going to do a certificate. Now, certificates can be generated by you on your systems. Your security servers like RACF, Top Secret, and ACF2 can become what's called a certificate server or a key ring for the certificates. But the issue is now I must distribute them through something like FTP to the users. Because as they come in, that certificate is going to flow. And again, we'll see this, at the end, hopefully got to have some time to go through security here. So that is, what I got to look at when I start building these IP services, if you will. Okay. Marching on. URI map. So the URI maps allow me to not have to specify information like host name, port, and the URI string to get an application. Basically, URI maps allow me, and this is the client one, this is the one we use in our own little class here that we teach, just because CICS can be the client. But rather than have the application have to understand or know the host name, ports, URI strings, it can be put into URI map, and then all the developers need to understand is the name of the URIs. So it gets all that, technical details out of their code and can be easily changed. So if I want to redirect to a different server, I simply change the URI map definition and the developers have no code changes to make, if you will. And it's a bit of a, effort on my part. It doesn't take long to define these, but, you'll have several of these things laying around when your CICS are clients. Typically, same kind of thing in reverse, front-end applications, a lot of cases, they define this kind of stuff in their code or read it in from some form of a parameter file, INI file, whatever they use. Okay, so a brief look at the URI maps. Second part of it, won't go through all these parameters, but I get to change the name of the transaction instead of using the CICS supplied one. And that's great for billing purposes or, chargeback or, something of that nature. But that also says that if I'm going to do that and separate out different transactions, again, I have to have different URI maps for each transaction. The security attributes here, you can see I would specify the ciphers and things like that. We'll talk a bit about security. And again, I'll show you the concept of web service and pipeline definitions, if you will. Probably the worst thing here is to deal with is code page. CICS is going to kind of do automatic translation from EBCDIC to ASCII, ASCII to EBCDIC, but based upon the code pages you specify. Now, your mainframes typically work in code page, and your emulators, terminal emulators, are working in code page 1047. It's a nice standard EBCDIC code page. What you're going to use for your web services could be all over the map. There's about 2,000 of them. Most people, hopefully today, are starting to look at Unicode and a standardization there. Your mainframe has supported Unicode for quite a while. Okay? And of course, continue on, again, you can see where I might find the HFS templates and things like that if I'm dealing with what amounts to HTML documents. Okay, Atom feeds. So the Atom feeds are basically really simple syndication, but the newer form, if you will, and the only one that CICS supports. It does not support the old RS. Publish and subscribe type technology. I can have my application say, I'm going to, or have CICS define these Atom feeds, and then somebody basically says, I'm interested in this, and then they subscribe to that feed, and then CICS will, or your applications can push out to all the subscribers, if you will, information. Okay? So kind of like a constant feed, stock ticker, news feed, like you might see running across the bottom of your TV screen, things like that. WSRR. WSRR is a product, a separate product, as it says, to hold web service definitions. When I define web services in CICS, and we'll talk briefly about the two utilities there on a separate page, but when I define the two utilities in CICS, or you set up utilities in CICS, I can have them automatically create the definitions necessary to go into WSRR. The advantage here, if I have a tool like RDZ or RAD, or just even a simple Eclipse with the CICS SDK in it, I can search WSRR through my IDE, say, show me web services that look like ABC, and at the same token, put up a list and then say, oh, I want item number 10, let's say. And basically, it can actually build the Java interfaces to invoke the web service. So WSRR is a nice little way of defining or holding, right, a directory, if you will, to hold all your web service definitions. And the CICS utilities will provide the information, to feed it. Just got to use it. Not free, by the way. Okay, so CICS is a client. Like I said, a lot of turf I got to cover, folks. Short time to do it. But basically, probably of becoming one of the more popular ways, HTTP definitions, or HTTP type protocol. Now, here we're talking about a client because we do that in our class. But CICS can also be the HTTP server. Okay? The commands are basically the same. We would have to establish a connection to the server, right? And that's done by our application when we do what's called a web open command. We then would do, as it says about the third or fourth bullet point, we would do web sends or converses. Yes, it will be conversational. So we can communicate to the server, so it's kind of a program-to-program communications, but it is, a true conversation, kind of what's something that we're kind of not used to in CICS. So we're susceptible to the fact that, we have to have a timeout, that if we don't get a response within a reasonable period of time, the application can fail or CICS can fail the receive or the converse, and we know that we've lost connections, okay? So those are kind of the environment or commands. HTTP kind of looks like this. We have a request line. For a request, basically. Post, which says I want to send a body of data. The headers here we're talking about are standard HTTP headers. CICS generates ones that we need most of the time. We can do our own. There are commands, so in my program I can write HTTP header or read HTTP headers, and I can get the headers in that way. But as far as the request, it's a standard HTTP request line that says we're doing a method of like post, which says I'm going to send you a body of the information that the application expects, and I will get back some form of a response, okay? But I wait on it. If I do a put method, it's an asynchronous put. I can just send piece after piece of data and never really get a response back. The get method says, give me information you got to give me. And of course, the other one is to delete the caching of information. There's a little bit more to it than that, but again, that can't be too detailed here. Probably the toughest thing in web services for the CICS folks is the second part, the status line, headers and body. Now the body in this case is whatever the two applications determine they need to send back and forth. The status line is the typical status line. You probably have all surfed the web and gotten things like 404s, page not founds, or 501 communications areas. That's what you get back in the status line. So my applications are required to test both not only the standard CICS command type responses, but also the status line coming back in the HTTP. HTTP is a standard, not an IBM standard. It's a standard uniform to all different kinds of servers. It's probably the cheapest way to do web services because all the software is pretty much free. The HTTP servers, you can pick up various various vendors for free, including like Apache. IBM has theirs built into CICS. We can have one on the mainframe itself. So it's the cheapest solution to implement and actually the least amount of overhead, we'll say, for web services. Standard HTTP bodies, your choice. And again, the commands. So I'm not going to go through this. Okay, so kind of changing a little bit here. Starting to get into the heavier lifting of web services. So what IBM has done, we used to have two methods of passing data. TWA, very old, COM area, 32K. Problem with COM area, and we can still kind of use it today, but the COM area is, basically a separate piece of storage. It is capable of corrupting things, cannot carry a lot of data. Data becomes unstructured, if you will. Can still use that today for what's called a provider application, although we in our class never push it or never recommend it. What IBM has built web services around totally in CICS is the use of what's called containers. As you can see, it's a named block of data. Okay. By the way, 16-character name, pickable by the developer. There's no resource definitions here. It says can be any length. Well, the largest get main I can do in CICS is 1 gigabyte. And that really is today's largest single, element I can put into, let's say, a COBOL working storage. That's with Enterprise COBOL version 5. Prior to that COBOL 5, the biggest single piece I could get was, or single element I could define was 128 megabytes. So there's been restrictions outside of CICS that held. But now, containers can be 1 gigabyte. Heaven forbid. Channels. Channels is a group of containers. Think of channels as nothing more than a list of 16-byte names. That's all it is. But now I can use this as a mechanism for passing data between programs. And the CICS web service implementations from IBM are highly dependent upon channels and containers. The last bullet point there in the middle says it's mutually exclusive with the COM area. So in our class, we have to, one of the key things we do is transition from COM areas to containers and channels. Not necessarily an easy thing to do, right? Time consuming, I shouldn't say not easy. It's a fairly easy process, just time consuming to touch all the code where you were doing COM areas and now do a container that looks like a COM area, let's say. Okay? And we go a bit deeper in that. But all the web services in CICS, the heavy lifting ones, are all built around channels and containers. And there's really no limit to the number of containers you can have. Okay, and there's probably on a channel in the standard web service environment CICS, probably about 30 different DFH containers. We're not going to get into that level of detail, just don't have the time. So benefit, no limit to the amount of storage that can be passed, right? I can structure the data, separate containers for different pieces of applications or different formats. The receiving program does not need to know in advance the sizes. We can find out the names, the size, etc. by simple commands, okay? And of course, the bottom bullet point, server program can be written to handle multiple channels. In other words, I can use the concept of different named channels to direct my program to do different functions if necessary, okay? And probably going to skip this foil and this one. Okay, now, commands. A bunch of new commands, 5 of them actually. Actually, start channels not totally new. But I now am going to have to deal with commands like delete containers, get containers, put containers, move containers, right? And basically creating containers on channels, right? Start channel, start a transaction, pass it a channel, as opposed to just a piece of data, if you will. And on the right-hand side of the foil, all the existing commands that have been changed, if you will. Assign commands, link, returns, XCTLs have all been changed to handle channels as opposed to passing of comm areas, if you will. And again, I can create the channels, as it says, by naming it on any of the commands you see there, right? So channels are dynamically created by programs. Nothing has to be predefined to CICS, if you will. Okay, so let's get into the web service quick and dirty overview. So what IBM decided to do for the heavy lifting stuff, HTTP is a very common thing we can do, but for the heavy lifting stuff, they decided to, focus around SOAP. And I got a description of SOAP, and what's called WSDL, or Web Service Definition Language, which is nothing more than an XML document, as it says. Definition using standard XML notation. Now, the WSDLs, or the WSDLs, are something that gets built by tools. Tools like the CICS SDK that's in Eclipse, or RDZ, or RAD, or the case strictly on a mainframe, a couple of batch utilities I will briefly show you. Okay. CICS can be what's called the requester or provider or both of web services. So it's really totally up to you. The other choice we have to make to use a standard implementation IBM does, which is the least amount of effort on your part, is if we're going to use SOAP, and we only support one, or IBM supports only one of two access methods, right? Transport, as it says, using MQ series to send the data through the network, or standard HTTP protocol across TCP/IP. As long as you can live with that, your implementation of web services in CICS becomes somewhat simple. Okay? Most of the stuff is done for us and becomes nothing more than getting, putting containers. So, the web service assistance on the next page. So CICS provides these assistants now. The two utilities there, LS2WS, language structure to WSDL, or WS2LS, WSDL to language structure. In a sense, are batch jobs that basically take COBOL copybooks and create the WSDL, or take WSDL and create the COBOL copybooks. So that basically simplifies the whole process. Now notice, however, the languages. So a couple of key things to note. No assembler, no Java. Now, of course, Java just finally got record structures. If you use these assistants, your applications get reduced to nothing more than getting and putting containers on a channel. You would never see the SOAP document like I'm going to describe here. Okay, you simply have the COBOL standard structure, or C structure, whatever you have on, whatever language you're using. If you want nothing more than HTTP processing, there are two other utilities that came into CICS-TS 4, schema to language structure, SC2LS, and LS2SC, or language structure to schema. Standard XML schemas, and the utilities can build them, and we can convert language structures to schemas, schemas to language structures. So now we are kind of going to have to do an XML parse, but that's about it. And again, I don't have the commands here, but in CICS version 4, they added two commands to CICS, transform XML to data, or transform data to XML, that can use the schemas and do the parsing for us. So it becomes quite a bit simpler to use these things and less coding on your effort, right, to deal with that. Okay, web service application, right, again, we can use the assistance, it becomes easier. It says we can also write our own message handlers. We can intercede in the CICS process and do our own message processing, but it's a little tougher, okay? However, people do use the standard IBM stuff and add a message processor, their own little transaction message handler, if you will, if nothing more to then produce an audit trail. I've seen that a lot in sites. The net result of the utilities, if you will, creates what's called the WSDL file and something called the WSBind file, and CICS uses this so that, again, CICS itself is doing all the transformation from SOAP to data structures, so we don't have to. Okay, I'm going to skip this. Don't have much time. And this. And this one, I think, too. Okay, pipelines. Very briefly, I, as a systems person, have to define pipelines. This becomes, shall we say, the logical transport across which all the CICS tooling works. And probably the biggest thing here that I am concerned with is the WSDIR. As I build my applications, as I build those WSDLs and bind files, they have to be made available to CICS, and that's done by the WSDIR. So that's kind of like the home, if you will, for all of my web services I define in CICS. Please notice it is not a PDS. These are being housed in your ZFS file systems. So they are truly directories on the USS side of the house. So we have to come up to speed there. But the pipeline is basically the way that CICS does all the tooling and processing to make it simple to implement these web services. Defining a web service. Basically, I define the name of the web service. And again, if I'm using the standard tooling, I don't have to define this. As I do commands in CICS, it will build a lot of this stuff automatically. SOAP. Let me skip this page. SOAP. IBM went to the SOAP standard, okay? SOAP basically is nothing more than a formatted XML document that has a envelope, and you can see the tag there within the less than greater than symbols. Within the envelope is a set of SOAP headers, standardized SOAP headers, and then the body, and the body is your data. Now the body that here would be typically an XML document, right? That would contain your data tags and or data elements. So SOAP really is Simple Object Access Protocol is the definition, and it really is nothing more than a well-formed standardized XML type document. In an application, we don't need to be concerned with this, although we can see all this on the channels. All this information is provided in containers on the channels we can see. But with this heavy lift of web services, heavy lifting style, we're reduced to nothing more than a get and put container on a channel. CICS is doing all the parsing of this for us. So that's all SOAP really is, right? And now, there are tools that can build SOAP documents. There are tools that can build the schemas for SOAP documents. And, there's actually testing tools, one called SOAP UI, that allows me to drive my CICS applications, without even having a front-end application. I can mock up a SOAP envelope and send it in, if you will. So IBM chose to do SOAP for the heavy lifting because it's a uniform standard that's being implemented by many different vendors. Okay? And it does simplify things or put things on a standard even basis. Couple quick pictures. So if CICS is the provider application, the requester makes the request, coming in, standard type request. And again, it's the SOAP document standard format. And everything in the big web service box that's in the kind of yellow shading is all stuff provided by CICS, with the exception of the WSDL and binding file, which get generated by those utilities, like LS2WS. So the pipeline, the data mapper, is all IBM provided code that does work with the standard SOAP. So my CICS application, the little blue box on the far right-hand side, is nothing more than getting and putting containers. Okay? Of the services you see or the definitions you see in green, the only ones I have to do as the administrator are the TCP/IP services and a pipeline. Web service and URI maps get generated as part of the tooling process. So again, becomes the simplest form. Quickly through requester. So CICS is a requester now. And again, within the yellow shaded box is all the CICS provided stuff. So my application is working with getting, putting containers. The binding file and the WSDL files, again, are generated by tooling. The web service definition is generated by tooling, and the pipeline I must define. So CICS can be both requester and provider, or both, as it said. So pictorially, that's kind of what it works. And again, simplest way to do it. Now, the heavy lift here, right? The requester and provider, this is a heavy lift. This is a lot of, a fair amount of overhead here. And I don't know if you've seen XML documents, but they can get rather, shall we say, lengthy, with all the tags and that. So, a lot of processing going on here, parsing those documents to give you a standard, let's say, COBOL copybook in your simple applications. Okay, some new stuff here. So CICS has implemented what's called WSDL 2. By the way, we're working with a moving target. With each new version of CICS, they're adding more and more of the newer web standards. But, some of these things are not cast in stone yet. Now, here we're talking about the things that Web 2 added, some endpoint stuff, message exchange patterns. Again, I can't really get into details, don't have the time. But again, it's all built around SOAP and XML. So what they've really done with the Web 2, or WSDL 2 standards here, is allowed us to now have binary objects included. CICS automatically encodes the binary data in what's called base 64. Think of it this way. It converts your binary data, and these could be, GIFs, GIFs, JPEGs, MPEGs, MP3s, MP4s, all kinds of things that can be stored, let's say, as large objects in the DB2 database. CICS doesn't care, can't parse them, whatever, but it will encode them in base 64, which essentially is taking 2 bytes and making it 3, so it can be sent across the wire and it doesn't get misconstrued as TCP/IP type control commands. It is going to increase the size of the body because we're now adding these binary objects. Several K, 100K, 500K, megabyte in size, right? These could be rather large. It attaches them, what they call MTOM. It basically attaches them, as you can see, as a separate binary attachment for what's called MIME, multi-purpose internet mail extensions. Think of attachments in your emails. So CICS is sending out the SOAP documents along with these binary attachments. That's been one of the major enhancements, right, in the recent version of CICS. So I can send or receive. Now, again, you are going to add the transmission time, you add the processing time because you're adding these large binary chunks of data. Your mainframe will be graphically challenged all of its life, but it will it will never render the stuff, but the whole purpose is to get it to a front end. Hold on here, I got a little question here. The presentation, somebody asked a question, the presentation can be downloaded from the link that I had in the first. Just get to our website, www.themusinc.com, and you'll find off of the front page where you can get to what's called webinars. And from there, you can find the PDF for this session. Okay. Briefly through security, I'm a little bit over, but it's only going to take me a few more minutes to close this out. Now, security is a concern here. So what they've done, 4 basic methods. Basic security, right? Something called WS security. The newer one, WS trust, and of course, secured sockets layers. So let me get through those briefly. So basic security allows me to do nothing more than supply a user ID on one of these 3 resources. We probably don't want to define 5,000 users to CICS. Maybe we can't if we're coming in through browsers. Think like a shopping cart. So basically, we can't override security. And CICS will use that, and we could do it either on the service definition, the URI maps, URI maps allowed me to be more granular by specifying URI map there. Problem. Simple implementation, very little work. Probably too simple, right? Easy to crack because I'm overriding security definitions. It's there, right? Depends on what you're doing. Now behind, and totally inside the corporation may be acceptable. Nothing coming from a web, but maybe within inside the corporate firewalls in your server farm might be acceptable. WS security. Standard. A lot of people put a lot of effort into it. I don't know of many implementations. Okay. It hasn't been fully blessed by any stretch of the imagination, but what it did is add special extensions to the SOAP messages. So I could have some form of encryption going on in the data plus headers. Problem is, it used user IDs and passwords, and thusly those were in the clear, but the data was not. Kind of strange. So advantages: I can authenticate user IDs and passwords. It does do some data encryption. It says not supported by CICS. Well, it is, but you have to implement special message handlers, as it says. It's not in the standard base product. I have to do some special definitions. Does extend the processing of the message, adds a bit of overhead. And it's also kind of a pain because it's done on a field-by-field basis within the XML document. SSL, probably the most utilized one. I can do authentication. I can have client authentication. I do have integrity confidentiality. Relatively easy to implement. SSL is a standard. It's a uniform set of ciphers that the world knows about. Okay. The thing that really makes it unique, or shall we say, the integrity and the confidentiality, is you develop your own keys when you do the ciphers. Keys, by the way, can be up to 1024 bits. Think of it this way: as we're talking about you trying to do a password of 256 characters. I'm pretty sure that would be hard for you to crack. So easy to implement, fulfills most of the security requirements. Okay. Disadvantages: about 5% overhead in CICS. Right? We have to manage certificates. That's the downside. Okay. But the data itself, the entire data package, be it HTTP, be it SOAP, is encrypted. So nobody can see it going across the network. You never want to give out what's called your private keys, only your public keys to the necessary people. WS Trust, fairly new one. We now have what's called token servers. Certificates, by the way, can be third-party authenticated through somebody like VeriSign, WS or eTrust, Thwart, whatever. With this new WS Trust, we must have third-party certificate, or actually what's called security tokens. A lot more different than the digital certificates. Can have more information. We can develop what's called trusted connections. It's just a newer way of providing the connections. And again, now we have to deal with third parties, so these are not free. CICS supports WS Trust, right? A little bit less overhead than WS Security, okay? And again, we do have to have third-party tokens. We can do self-signed tokens with our mainframe security systems, but again, that would not be acceptable across business boundaries, okay? Advantages: we can do authentication faster than WS Security. It says not yet sanctioned by OASIS, fully not blessed. It's not cast in stone yet, shall we say. It is available by adding a couple of extra message handlers, okay, and it does extend a bit. CICS will automatically go to the token server of your choice, be it Thwart, eSign, or VeriSign, eTrust, whatever it may be. That's it. And I went over by about 10 minutes. So sorry about that, folks. A lot of turf. Hope you learned something. And by all means, if you got questions, send me an email. So go have your lunch. I'm going to sign off now myself.